All right, to get started, we have this quick pull 9 plus a negative 25. This is one where maybe we want to start looking at drawing it with a number line model instead of a tile model, just because this will be a little bit difficult to model with, not difficult, but a very time-consuming one to model with chips and tiles. So pause the recording to give yourself a chance to get this done, and then we'll talk about it when we come back. Okay, now that we are back, in our warm-up notes, we're going to be including a model for this. I prefer the number line model. And again, my number line model is not going to be 100% perfectly detailed. I'm just going to keep it pretty generic, where I'm starting at 9. So if this is 0 here, to start at 9, I'm going to be going up 9. And then I'm adding a negative 25, which means I need to now, from that point, go down 25. And I want you to think about what this is going to look like. We're kind of breaking this up into two pieces here, because the first 9 that I'm going to be going down are going to get me to 0. I still have to go down the rest, and it's that rest that's going to tell me how much more I need to go. So we kind of talked about how can we see the 0 pairs in a number line? We kind of can. We can see it here in how it's sort of overlapping like that. So I'm supposed to be going down 25 because the negative 25, the first 9 just get me back down to 0, which means I have the remaining 16 more to go in order to get the full 25 down, or negative 25. So that means I ended up here at negative 16. The fact that you guys didn't draw models for that at all and were able to think about that mentally is pretty impressive, and good job to you guys. Let's pick up where we left off last time, which was 2.1b. We only made it halfway through, and we're going to finish that lesson today. So 2.1b, go ahead and give yourselves a second to get that out. I'm going to pause the recording while they do. Okay, so we're actually going to be taking another look at these 4 stories again a little bit later on in today's lesson. So I want you to get started by reviewing those 4 stories. How did we model them? How did we answer the questions that were being asked? Just take a quick second. Let's refresh everything, review with your groups. What did we do on this first page? What were these stories? Ready, set, go. Pausing the recording. All right. Anyone want to summarize any of the work that we did here on this front page? Thank you, Sophie. Good. Yeah, and the pictures helped us a lot, but really, truly, I want you to make that connection that the pictures were usually kind of some rough sketches of number lines. Whether we realized or not, when we were drawing these pictures, we were drawing rough sketches of number lines. Another thing that I would like to point out is how very quantitative each of these are. Math practice 2. These are all real stories. We solved the problems from a quantitative perspective, and then we're going to start translating that to be more abstract and how we can do this with just numbers and kind of take that context or that situation out of it. Let's see where we left off. I think it was right here. Okay. And then I asked you to complete these as homework. So I'm not actually going to be coming around and checking your homework. I'm not going to come to see who did it and give you points for that. But I'm hoping that the fact that you did it is going to start your discussion now. Number 11, you should have modeled 7 plus a negative 3 on a number line and with chips. And then discuss with your groups how those models are related. We already saw this one worked out for us. This one you were doing on your own. So compare with your groups and discuss question number 12 with your groups. Ready, set, go. All right, here are my representations. I've got my number line where I went from 0 to 7, and then to represent negative 3, I went backwards, 1, 2, 3 on the number line, ending right here at 4. My chip tile model. Once I combine those, I can see I've got some 0 pairs here, and it leaves me with 4 of these positives. So I end up with positive 4, just like I did on the number line. So how are they related? Please now share your conversation that you had with your tables with the class. How are the number line and the chip and tile model related? Thank you for getting us started. Tanner. Yes, we can represent integers both ways. How else are they related? Gideon. They are both models, yes. Are we seeing, let's talk more about like the, I don't even know what the right word is, the mathematical relationships that we're seeing in each one of them. How are they related mathematically? And that's when no one wants to participate. Gideon, do you have a thought? No? Are we representing positives and negatives in the exact same way for each model? Okay, let's talk about how are we representing positives in a number line? Joshua? Yes, an arrow pointing to the right. And how am I representing positives using the tiles? Now that's going to change for each person, right? Some of you are doing plus signs like me, positive signs. Some of you are doing blank squares. Some of you maybe are still drawing balloons. But we are picking some sort of representation. And how is that different from how we're representing the negatives? If an arrow goes to the right for positive, how am I representing negatives on the number line? I'll just keep waiting. I'll repeat the question one more time. We represent positives, as Joshua said, with an arrow going to the right. How do we represent negatives? Alexis? An arrow going backwards to the left. And how are we representing negatives with the tiles different from the positives? And again, that answer can vary. Some, maybe it's negative signs, some maybe they're shaded in. Cambria? Yeah, for some, the negative would be shaded in, but the whole thing that I really want you to make sure you understand is make sure that it's different, right? Whether you're leaving one unshaded and one shaded, whether you're writing positive signs or negative signs, just make sure that you are differentiating. My 8th graders were struggling with that with the recent activity, and they weren't making that distinction, and that it caused some issues. So just make sure that you are making that distinction. But I want you to also notice, can we identify the 0 pairs in each model? Where are we seeing the 0 pairs in the number line? Discuss that with your groups. Where are we seeing the 0 pairs in the tile model? All right, and where are we seeing those 0 pairs? Come back to me now. Where are we seeing the 0 pairs? Thank you, Leroya. Yes, where the lines overlap, we are seeing the 0 pairs. Just like you can kind of consider it here. When we're seeing some overlap here, we can consider that kind of the same thing there, okay? So, I'm going to not be able to move that around. All right, so the rest is just a whole bunch of practice using these number lines. We want to try and get away from having to draw chip and tile models all the time. As these numbers get increasingly bigger, it's a lot of extra drawing to do. But for today, even if you feel like you're at the point where you can do this mentally, I want you to draw the number line models for each one of these. Let's do the first one together. 6 plus a negative 3. So the first thing I need to do is represent the number 6. The number 6 is positive. So starting at 0, I'm going to draw a line going to the right, since that's how we represent the positives, until I get to 6. And again, I have the advantage of doing this. I can start at 0 and draw a line going to the left that goes to negative 3, and then I can pick it up and move it. You guys can't do that quite as easily. But when I pick it up and move it, I know exactly that it's a length of negative 3, and then I can stack it and see that it takes me right here to 3. So 6 plus a negative 3 is equal to 3. And our strategy really truly doesn't change if we have a horizontal number line or if we have a vertical number line. So let's do this next one, negative 3 plus a negative 9. And you can still check your answer using these chips and tiles. Negative 3, that's going to be 3 rocks, plus negative 9, that's 9 more rocks. So I hope we understand that we're going to be left with rocks. And that helps us to check our answer as we draw negative 3 now. 1, 2, 3. And then from there, I count down another 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And where did I end up? It looks like I ended up right here at negative 12. Again, negative confirms, just like we had suspected before, that rocks plus rocks is going to equal even more rocks. So that is all that I am going to do to lead this video. I'm going to let you guys work with your groups. We'll come back and we're going to put the answers up on the screen, but we're not going to do that as part of the recording. We are going to pause the recording, and then magically all of the answers are going to appear in the recording. So just keep that in mind. Pause the recording long enough that you can do this on your own and then check your answers. Pause the recording now. All right, there's the answers that students put up on the board for 14 through 17. Then we're going to scroll so that we can put the answers down here as well. Again, pause the recording because the answers are magically going to appear. All right, answers are on the screen. Take a look. You can see the models from the students. And now the last couple here, 20 and 21. Pause the video because the answers are going to appear magically. And the final two answers here. All right, numbers 24 through 27. Let me just explain the formatting. On 24 through 27, it says the same questions from the exploration at the beginning of the activity. For each context, use a number line to model the problem. So really, truly, we've got the same problems. Don't worry about that. It's the same problems as the front. Here's the number lines that I provided for you. And they're kind of following that same number structure. So 24 is dealing with this one, and that number line is now big enough for that problem. So finish up there. And then 28, you get to create your own numeric expression that matches what you see here. And then after creating the numeric expression, make it quantitative. Create a context or a story that's going to model that. We saw some quantitative examples. We saw some stories that we can write number sentences for and then model using the number lines, and then you're going to go backwards here. That's how we're going to finish class. So let's see if we can finish all of that in the next 4 minutes, again with your groups, and then we'll talk about them together. So let's go 4 minutes with your groups. Ready, set, go. Pausing the recording. Okay, so number 24 is like number 1 at the beginning of the task. An osprey flies off the ground and reaches 35 feet above a river. When he sees a trout, he then dives 37 feet down to get the trout. How many feet below the water does he end up? We're going to have that modeled up here on number 24 by Oren. Go ahead. Showing where the osprey is currently, 35 feet above, diving down 37 feet. Ending at -2. Fantastic. Now, it doesn't say to do this, but I want us to all do it anyway. I want us to write the mathematical expression. What's happening? We're starting at +35. And what are we doing? Go ahead, Dylan. Very good. We're adding a -37. That's exactly what we're doing. And I want you to keep that in mind because in number 25, you're going to be tempted to write it as subtraction, but I want us to talk about it as adding negatives. So 25, we're going to model this one. This is going to require a couple of them. 35, 12, and 8. So we start here with a 35-yard gain. I already forgot. Is it 12? Okay, a 12-yard loss, that gets me to the 23, and then an 8-yard gain. What is the result? Is it 31? Is that what we decided? Okay, so what is the mathematical expression here? Will you quickly talk with your groups? What is that expression? What are we doing? Let's talk with our groups, please. All right, who is brave enough to share it now? Good. What do you think it is, Grant? Yes, for number 25. Yes, I like that a lot. 35 plus a -12, adding a negative integer, and then adding 8. And the result there is 31, +31. Good. 26, just for the sake of time, I'm going to make this one also pretty quick doing it on my own. Walk 3 miles from our house to the store, and then meet up with a friend. Walk 2 miles back towards the house. So where do we end up? At 1. And the expression is going to be 3 plus a -2 is equal to 1. Can you also think about it as 3 minus 2? Yeah. In this problem you can, but I just want us to also make that connection that we are talking about addition of negative integers. In the past we may have modeled it like this, but now we have more tools and now we can model it 3 plus a -2. You ride your bike 12 miles and then get a flat tire, so you turn around and walk the bike 8 miles before your mom can pick you up. So we're going forward 12 miles and then have to turn around and come back 8. There's 1, 2, 3, 4, 5, 6, 7, 8. So we end up here at 4, and again we can model that with 12 plus a -8 is equal to 4. Yes, Grant? Are you sure? Okay, even though we only walked 1 mile back in the original problem and we only walked 4 miles back in the original problem, you can still see that they're so closely related, and I will fix that in future versions. But now it's time for homework. Your homework is the 2.1b homework section. The first one is already done for you, so don't freak out figuring out what do I need to do. It's already done for you. It's just showing you again what we've been doing. So yes, it is all the problems in that homework section. Any questions? All right, go ahead and get cleaned up.